Welcome to homework.
Okay, we have a figure in which we're shown chambers A, B, and C, in which A contains 6 moles of gas, B contains 12 moles of gas, and C contains 9 moles of gas. And we're also told that volume A equals volume B equals volume C, and that temperature A is equal to temperature B is equal to temperature C. So they all contain the same volume and temperature. And the question is, which of the three bulbs has the highest pressure and why? Okay, so for one, the answer is B. Why is it B? Because if we're maintaining volume and temperature, then by increasing N, we will increase the pressure. Remember, PV equals nRT, right? So solving this purely for P, we divide both sides by V and get that nRT over V is what P is equal to. Well, note that V cannot change and T cannot change, and R is a constant. It's the gas constant. So if I draw in red R, T, and V, which we say must stay the same, then the only variable that can change is N. Really, we have N times RT over V, and these values will remain the same. So how do we make something have higher pressure? N must increase. If N goes up, P goes up. There's no other options because we cannot change anything in the parentheses. Okay, so which of the three bulbs has the highest pressure? B, if they all share T and V, then N is the only variable which can change. And P is proportional to N. That is, higher N implies higher P. Therefore, the bulb with the highest N B must have the highest P. Okay, on to question 2. If the pressure in B is 1 atmosphere, let's say P sub B equals 1.0, what are the pressures in A and C? Assume V and T are constants, and each small dot represents 1 mole. Okay, well, notice that if NB equals 12, that NA equals 6, and NC equals 9, right? Because we're told that each dot is 1 mole, and it's how many moles of gas we have. So PB equals NB times RT over V. And we know that this means 1.0 atmosphere, which is what PB is equal to 12 times RT over V, which means that if we divide both sides by 12, and this is units of moles, we get 1.0 atmosphere over 12 mole equals RT over V. Well, RT over V are the same for B and C, which means that to figure out the pressure of A or C, we could use this information. We could plug in RTV and say, PA equals NA times 1.0 atmosphere over 12 mole. But the shortcut then is to really just say what we're going to get is that since Na equals 6, this is going to be 6 mole times 1.0 atmosphere over 12 mole. We're going to get 6 over 12 is 1/2. We're going to get half an atmosphere. Right? It's really just the proportion of moles times 1 atmosphere. Proportion of moles to an A to the number of moles in B times 1 atmosphere. So for C, we can sort of shortcut and say PC equals 9 mole times 1.0 atmosphere over 12 mole, or 0.75 atmosphere.